Okay. So we are very pleased to have today with us in our Bar-Ilan University Vision Science Seminar, Professor Melissa Lê-Hoa. I hope I'm saying this correctly
I
because,
told you just to say Melissa is here. It's fine.
okay.
We're all good.
Um, okay. From LMU in Munich. Melissa is a professor for neurocognitive psychology at the Ludwig Maximilian University in Munich, LMU, and the head of the Scene Grammar Lab. She received her diploma in psychology from the Free University in Berlin, working with Professor Arthur Jacobs, and moved to Munich, where she did her PhD at LMU on the allocation of attention and scene perception with Professor Werner Schneider. Following her increased interest in scene perception, she moved to Scotland for a postdoc at the University of Edinburgh to work with Professor John Henderson. After that, she moved to work on issues of scene guidance during search with Professor Jeremy Wolff at the Harvard Medical School. Melissa then moved back to Germany, where she was appointed full professor for cognitive psychology and set up the Scene Grammar Lab at the Goethe University in Frankfurt. After that, and actually recently, in Munich, she set up her Scene Grammar Lab. And after that, she moved just recently to LMU Munich, where she became the new head of the Neurocognitive Psychology Chair just now in 2025. Melissa's work has been supported by numerous grants and fellowships, including grants from the NIH and the German Research Council. She's the winner of the 2018 Elsevier VSS Young Investigator Award. She's also an author, the author of dozens of peer-reviewed papers, many of them highly cited. In her research, she developed this concept of scene grammar, particularly scrutinizing the distinction between semantics and syntax in visual scenes. Her work uses eye tracking and EEG techniques in both children and adults to demonstrate that brain processes semantic and syntactic visual information differently. And she has shown that scene grammar not only aids visual processing, but also plays a key role in efficiently guiding search in real-world scenes. Her work has implications in multiple areas, ranging from computer science to psychiatry. She's also an award-winning teacher. And without further ado, I'd like to welcome you, Melissa, to our seminar to hear about your exciting research. And thank you so much for joining us.
Thank you very much, Sharon. This is an amazing introduction. I feel like I don't know if I can add so much anymore in this talk. You basically gave the essence of what I will be showing you today, and I'm very glad that it finally worked out. I remember Sharon like inviting me informally when we met at VSS, I think 3 years ago when I was pregnant with my third. And I said, yeah, let's do it soon. And 3 years later, we're here. So thanks for your patience in asking me over the years. I'm very, very delighted to be here. You will see that the talk that I'm giving today is really more basically a more fleshed out introduction to scene grammar than you have already done greatly. And I'm putting work with Jeremy in there, more latest work. But I also wanted to give space for people to ask me questions and also still invite me to their labs in person, because I feel like this is also kind of fun to be there. So I'm not showing you all the latest and greatest, but I think I'm giving you a broad overview of what we will be doing. So please do ask me questions in between. If there's something that you don't understand or you have questions, I'm totally fine with stopping in between. And I didn't time it also, so just, cut me off at some point, holler if I don't see you or something like that. And other than that, we can just go with the flow. So I titled this Reading Scenes, as you will see, because a lot of the inspiration comes from analogies to language processing. And I will basically start with this. You might be wondering why this lab is called the Scene Grammar Lab. Don't know if you've ever wondered. So I like to kind of give this example here. So you have probably never read this particular sentence before, but you have no problem understanding it. This would be very different if I would move things around. In this case, would destroy the syntax of the scene, of the sentence. And we can do something quite similar with scenes. So this is one of our VR scenes that we use. And everything is as you expect. And if you kind of destroy certain regularities that we are usually experiencing, you might have difficulties understanding the scene and finding certain things. So that leads right into my, of course, first demonstration. After having spent many years in Jeremy's lab, you learn that you need to wake people up at the beginning with a quick demo. So since the lab is very interested in how scene grammar also guides search, I would like you to clap your hands when you see the chalk in the next scene. Okay, it's coming up. I hope you see it over here. You have to unmute yourself, I guess I should say beforehand, because you might have clapped and I didn't hear it. But you have your webcam on or not, or you have it activated. And that means I was able to track your eyes more or less. And I'm showing you typical eye movements of people when they're asked to search for the chalk in here. And what you will see is that the scene coverage is very little. So 14% in this particular case, which translates to 86% of search savings, which is incredible for, a complex scene when it comes to like features and colors and shapes and stuff like this. This is very different from the types of search that you would be classically thinking of when it comes to visual search. So you would look for the wide horizontal. Again, maybe you can unmute yourself and just clap your hands when you find the wide horizontal in the next scene. Coming up. Yeah, there's one. Exactly. Sharon found the second one as well, right? And you might have already felt the difference between those two, and we'll talk about that difference in a moment. So the outline for today's talk will be, I'll talk about attention and perception in real-world scenes, about the hierarchies in visual cognition, about scene search and memory. That really goes back to work that I did also in Jeremy's lab, and also work that we have been doing in the lab, even though we're not a developmental lab, but I'm very interested in this concept of how the scene grammar develops over time. Okay, let's start off here. This is actually a model that we proposed when Carla and Michelle and I were in Jeremy's lab, kind of trying to explain the difference between the types of searches that you've just performed. So in the case of this more like classic visual search, the sources of guidance were features mainly, and in order to find the target, you have to focus your attention and bind the features together to recognize the target. And that is different from what we've experienced when you were looking for the chalk. Here, in addition to the selective pathway, you have a non-selective pathway, which gives you a kind of gisty processing of the scene. You're able to say this is a classroom scene without having individually recognized each and every object in there. And based on your knowledge about where certain objects should be in that scene, we call that scene grammar, you were able to reduce your search space, and then you can go bind features and recognize this object. And that allows you to be very efficient in naturalistic search. And so over the years, I've been really interested in finding out what exactly is this scene grammar? What is this type of guidance? What makes it so special? So I like to draw those analogies to language, not only because before I started my PhD, I was only doing language research, had nothing to do with vision before my PhD, but also because I think it's quite inspiring, even though I'm not saying that language processing and scene processing are the same thing. So we have strong expectations about what objects fit a scene context and how they relate. And similarly, we have expectations about what words fit a sentence context and how they relate to each other. And very roughly speaking, you could say that some of it is more semantics and some of it is more syntax. And one of the main reasons I moved to Munich was because we have this perfect example of double inconsistency here. So you have the Alte Utting, which is in the beautiful part of Munich, Sendling, where you have the inconsistent object semantically because it should be, in a lake area and not on a street scene. But it's also syntactically inconsistent because it should be kind of resting, floating on water and not, sitting on a bridge. So this is something that people have studied for a long time, the collected works of Biederman and people. Here you see an eye movements of people that basically I recorded when we told them to just memorize the scene. And you can see that this person is coming back and back and back to that floating printer in this case. And you have even difficulties recognizing it as a printer because it's just out of place, right? It's floating. It shouldn't be necessarily in the kitchen on top of a stove and so on. But we never were able to distinguish between what we just called semantic and syntactic processing. We just saw that people looked longer at those. So when I was in Jeremy's lab, I was able to finally try out this experiment where I wanted to see if brain potentials can differentiate between semantic and syntactic processing of those objects. And why EEG? I mean, we recorded this there because we know from sentence processing that there are markers that hint towards more semantic or syntactic processing. So if you have a sentence like every morning at breakfast the boys would eat versus a sentence every morning at breakfast the boys would plant, about 400 milliseconds after you hear or see the word plant versus eat, you get this negative deflection in your brainwaves, which tells you something about how well you were able to integrate the semantic concept into the context of the sentence. On the other hand, if you have every morning at breakfast the boys eat wood, you basically just change the relation of those objects, but not the semantics. You don't get this N400. You get a later positive deflection, which has been attributed to a reanalysis of the syntactic properties of the sentence. And so I was just curious if we can see some kind of diverging brain potentials for those two types of inconsistencies. So later on, I'm showing you now, this is a later data set or image data set that we created with one of my PhD students, Sabine, in Frankfurt. Back then, when we did the study, I actually went around and took pictures of Jeremy's home and Todd Horowitz's home and Carla Evans' home. This is actually a data set that we published later here. So you have a consistent object. You have a semantically inconsistent object that we tried to kind of match with size and features and stuff like that. And you have a syntactic inconsistency where a perfectly fine roll of toilet paper is in a position where you would not expect it necessarily. And those we put together in the CGRAM database. So if you're interested in a well-controlled database, I think this would be something to at least look into, where we really crossed semantic consistent objects into different scene categories back and forth, and took great care in putting this up. And we use this database in later studies, but and also pre-formats here to look at the differences between brainwaves. And so here you see a consistent control condition. What you now would expect from language processing literature is if you see a semantic inconsistency, it would be a negative deflection somewhere in this N400 time window. And this is basically what we found. We found also an earlier component in the N300 time window, which has been attributed to perceptual processing difficulties, which might tie nicely back into the classic studies of Biederman, who in the 80s also showed that objects that are semantically incongruent with the scene are really hard to even identify before you integrate them semantically even. And then here, interestingly, for the syntactic inconsistency, that was just not simply a reduced semantic response. It really looked like something conceptually different. So we interpreted this also like a syntactic reanalysis of the scene rather than semantic integration difficulties. And when we looked at the scalp topographies, you could also see that they really had something categorically different going on. We later on in the lab used particularly the N400, so semantic incongruency markers, to look at various things that could be affecting object processing in contexts. So this is Tim Lauer, who used to be a PhD in the lab, who did a series of studies to look at the effect of textures and inversion and materials and so on. You can read also a very nice overview and a review paper on this, where we really use this particular EEG marker to better understand semantic processing in scenes. So I think it's something interesting to kind of use as a method. So to summarize part one, those similarities in brain responses between language and scene processing might imply that there could be some similar ways of utilizing context for predictions, so words and sentences, objects and scenes, maybe even notes in music, right? So Patel had a great study back then. I think that is worth mentioning. Also, Biederman already said that something roughly analogous to what may be needed to account for the comprehension of sentences is required to account for the speed and accuracy of the comprehension of scenes never experienced before. So the idea of grammar is really that with those rules, you will understand sentences or scenes that you have never seen before. And that is something very powerful. And I believe that the ability to generate predictions from context and using the scene grammar is the key to efficient object search and perception. Okay. Next off, I wanted to show you how we then developed this further. So this is work together with Sage and Dan, Sage was a master's student in the lab, and Dan was basically one of my first PhD students. They're both now very successful professors at Oxford, have a beautiful little boy, and are doing really great. So it was a pleasure for me to work with them. And what we were looking into here was the idea, again, borrowing from language, that words and sentences are not created equal. They have different purposes that they fulfill. And similarly, you were wondering, what are hierarchies in scenes? So what role do certain objects have in scenes? They're not created equally, obviously. So what kind of structures can we find? And so what we did here is we looked at scenes and tried to figure out what are they really made of. And so what you can do is you can basically subdivide scenes into subunits that we called phrases. So they're basically a small group of words or objects standing together as a conceptual unit, typically forming components of a clause, or in this case, a scene. So we called those subunits phrases. At the heart of those phrases are what we call anchor objects. They're larger, less movable objects that, and that is the important thing here, give us very strong predictions about not only the identity of other objects that we usually interact with, but also their location within a scene. So the working hypothesis here is that scenes are hierarchically organized with phrases centered around those anchor objects, and those anchor objects hold very strong also spatial predictions. And this is important when it comes to understanding search in scenes regarding those other local objects that are part of that phrase. So we wanted to first test, does this idea that we had actually explain some of the search data that we were looking at? So we wanted to see if anchors guide search. And for this particular question, we came up with a paradigm. We used the flash preview moving window paradigm, where you flash a preview, then you cut it off, mask it, you tell then people only what they're supposed to be looking for, and then there's a gaze contingent window moving around. In this case, the manipulation was quite simple. Here, they were looking for the toilet paper, and what we did is we either had an anchor object, in this case, the toilet present, or we swapped it out with something else in the scene. So I don't know how it is in Israel, but I remember this was creating huge difficulties in the US because having a washing machine in the bathroom was a no-go. We have that all the time here. I'm looking for apartments in Munich, and there's always washing machines in the bathroom. So, but in showing those scenes in the US was creating things that I was not intending to create. The main manipulation is really having an anchor present or absent, or in this case, swapped. And what you see here, just if you look at reaction times, is that reaction times go up when the anchor is taken away. And when you look at eye movements, you can see basically at the distribution of this that the scene coverage also increases less, as a search gets less efficient when you take away that anchor and substitute it with another object that is usually semantically consistent with the scene. But we wanted to get away from this kind of, yeah, this is an anchor, this is not an anchor. So together with Sage and Dan, we tried to come up with a measure of anchorness. For that purpose, we used graph theory. Basically, we put nodes on top of each of labeled images. We connected them with edges. And the important thing here is now the weighing of those edges. So we extract object pairs, and what we did here is we strengthened the weight of object pairs that occurred often together in close proximity, that had a low spatial variance, so they would either be always in this constellation rather than kind of changing that constellation often, and whether they were in the same cluster. And with this basically weight calculation, we went back into our old data set. So we used imaged data sets, like back then it was LabelMe, to calculate those weights for particular groups of objects, like the toilet paper, put that back into our experiments. And as a sanity check, you could see that when the anchor was present, those anchor weights were higher than when they were swapped. But more importantly, now we can get rid of this binary, is it an anchor or not, distinction, and have a more continuous, fine-grained idea of what is an anchor or not, or to what degree an object is an anchor. And that allowed us to see that the presence of anchors modulates, even on a single trial, the search behavior in naturalistic scenes. We then took this into 3D. So this is work done again with Dejan, but also with a super clever, back then bachelor student, now he's finished his master's. Great person to have in the lab, Jason, where we tried this out in VR. And the way we did that, we had a 2x2 design. We had anchors either present or absent. Absent here, they were not swapped. We basically just grayed them out and substituted them with cuboids. Or we could, that was this distinction, or we would have syntax basically of the objects being intact or inconsistent with your expectations, everything basically tossed around. Just to give you an example here, you can see people now looking for toilet paper. Those are the eye movements that you see. And this is a perfectly fine scene. Anchors are there. The syntax is consistent, right? So this is quite easy. Now we exchanged anchors with cuboids, and you would think in this particular scene even, maybe it doesn't make a big difference, right? There are some shelves and some cupboards and stuff like that. So that was something to look at. Then we had inconsistent anchors. So here you can already see that this is a huge difficulty when you're searching for object and everything looks like somebody broke into your house and threw everything around. And then the double whammy is basically everything being inconsistent, but cuboids replacing those anchors. So what did we get out of this? We see those 4 conditions here. On the y-axis is the response time, basically as an output of the linear mixed effect models that we used. And what you can see is, again, when you take away the anchors, your response time goes up when you're searching for objects. And the inconsistent case, what happens is if you take away the anchors, it's actually helpful because it probably diminishes clutter and also gets away expectations that you still might have that some objects might be close to your anchor, which will not be the case in an inconsistency. And you see that across a number of dependent variables that we looked at in eye movement land, and it basically shows in all of them. What the nice thing is with VR is you can also see the eye movements in 3D, and it's pretty clear that this inconsistent way of setting up a room is very disturbing, but also taking away and graying out those anchors leads to less efficient search in 3D. And you can also see that in body movements. So what you can see here is blue lines is how the people move their body. And you can see in the consistent version, when the anchors are present, they're basically standing still and just finding objects. They basically have to kind of point a laser to where they think the object is. When it's inconsistent, you see that people have to, of course, also run around and look around those objects. But also in the cuboid condition, you can already see that the body movements get less efficient. They have to walk around a little bit more to look at things. So to summarize part 2, anchor objects play, I think, a unique role when we interact with our real-world scenes. We can also later on talk about, Lea is here in the audience, who's a PhD in the lab, who's working more on action, perception, and the effects of actions in scenes. So we think that also this kind of whole phrasal structure is, when you think about indoor man-made scenes, something that is very action-driven, because we create our world to be as efficient as we can be. And I think they need to be considered for understanding the efficiency of scene perception and object search in naturalistic scenes. Okay, then I think another important component of especially visual search is the influence of memory. This is also work that I started when I was in Jeremy's lab. Also even started a little bit earlier when I was doing my PhD here in Munich, but as you will see, it's a topic that keeps me busy, and I think it's still very interesting. We know that people have an amazing ability to memorize objects and scenes. So Talia Conkle has shown it, Tim Brady, standing in the 70s already. We have shown it ourselves. So this is a highly replicable finding that people have an amazing memory. So when it comes to search in naturalistic scenes where we have objects and scenes, you would think that search is highly memory driven, right? So when I'm in this French kitchen and I'm making breakfast and I'm looking for the jam jars, you might be looking around and you will find them over here, right? We can track your eye movements. And what you see as a typical kind of scene grammar output is that people have an idea where they should look. They're not looking out the window. They're not looking on the floor. They're not even looking on top of the stove, right? So you can see it's kind of fine-grained even. So they use their scene grammar to look for where they think this jam jar should be. This, in this case, was 16%. But when we make breakfast, for example, we don't just hop from one scene to another like we do in a lot of our experiments. We stay in the same scene and we look for different objects in the same scene, kind of the repeated search paradigm. And so now let's do it. Now you're looking for the eggs for your breakfast. You look around, you find them over here. You look for the pan. You look for the baguette down here, right? And you will be exploring the scene while you're keep looking for those objects. Of course, in France, you drink wine for breakfast and so on. So you do this for a certain number of times. In our particular case, we had people search for 15 different objects in the same scene. And so the hypothesis here would be that since memory is so strong for objects and scenes, you should really be able to, in the end, at the 10th, 11th, 12th object you're looking for in the same scene, after spending many, many seconds in the same scene, you should be getting faster. And what we found is basically that this is not the case. People don't actually get faster when they're repeatedly searching through the same scene. And we thought it was weird, even though Jeremy had previous findings that pointed at this, but we replicated in this particular study it 4 times and they never got faster. And so we tried to look at this also slightly differently. We had people look for the jam jars the very first time. So this is what I just showed you. But then we also had a condition where we told people, look at the scene. You have 30 seconds time. Look at the objects in the scene. We will later test your memory about it. And then we asked them to search for the jam jars. And what we found is that they again kind of get into this mode of using scene grammar to look in probable locations rather than using memory that they might have. They're not using it when they're searching for this object for the first time in that scene. So it seems that in a regular scene, episodic memory might be less efficient than using scene grammar. As O'Regan already in the 90s put it, the world is an outside memory. If the world is stable and predictable, we don't need to memorize it over and over again because that might be faulty and it might just be faster to simply search again. But what we found is in this particular study, we had them search for different objects in the same scene across various scenes. But then in a second and in a third block, we asked them again to look through those scenes for objects that they had searched for before. And what we found here is the first search was this, I showed you that. Second search, they were quite as big. They basically have their search area the second time after hundreds of scenes that or trials between the first time they searched for the jam jars and the second. And the third time, they basically just go there. So there is memory. They're creating memory. And in this particular case, they're able to use it. So we were wondering if this is maybe a task-dependent effect. And so what we did in this particular study is we contrasted people incidentally encoding object information while they were searching versus intentionally memorizing objects for a later memory task. So what we did here is we had 10 different scenes with 10 critical objects in each. We had 2 blocks, and in each of those blocks, they had different tasks. In one task, they were asked to search for objects, and the other one, they were asked to memorize objects. And here we told them that we will specifically probe their memory. Afterwards, we tracked eye movements. We, of course, counterbalanced which task came first. And in this particular case, we had people draw the scenes from memory later on and then counted how many objects they correctly remembered. And we also, of course, always changed the assignment of which scenes were being searched or memorized across participants. And so just to give you an idea how that looked like, we had 10 different targets in the scenes, and in the search task, we would tell them what to search for, basically what you just did, right? And they would search for a particular object. They would go somewhere else in a different scene. They would come back again to the same scene and maybe search for a different object and so on. In the memory task, we told them, those are the important objects. You have 20 seconds to memorize them for a later memory task. And at the end of this, and so we did this for the 5 different scenes, we had them draw the scenes. Of course, this is highly dependent on how well you can draw, but we told them, just also make an X or a circle and label it if you don't feel comfortable drawing a baguette or whatever, just as an example how this could look like, right? And then back then it was Dan basically doing the hard work of putting this into object memory terms. But this way we were able to look at what people recalled. And what we found, which was against our intuition at first, was that the recalled number of targets that people came up with was twice as high in the search condition where they really only incidentally encoded them. And when we looked, though, at the eye movements and just kind of looked at how long people had focused on those particular critical objects in the search versus memory condition, we saw also that they had just simply looked longer at those objects. So that was a little bit stupid. And so we tried to kind of pimp the memorization phase by increasing the gaze durations on objects, marking objects one at a time. Maybe that is different if you have all of them present at the same time. We also provided labels for each object, and basically we made the memory condition as similar to the search condition without them actually having to search. And so basically the memorization condition kind of looked like a search condition, but we told them immediately where the object would be that they had to memorize. So here we found that the gaze duration, if at all, would be going in the other direction, but the targets in the search condition were recalled to a greater degree than the indicated objects in the memory condition. So this is a finding that we then, based on the difference between looking at and for objects and scenes, we termed it the search superiority effect in later papers then. And we have replicated it many times in our lab. And I want to show you a last version of this that we did in our lab using, again, VR and people, looking around in scenes while they're moving also around. We had a search condition. This is, again, with the Jason that I introduced to you earlier, one of his other projects that he did, and a memory condition. And to give you an idea how this looks in VR, so here you would be primed by, a word queue, and then you would be looking around in perfectly fine scenes. So there's no manipulation of the scenes here, right? So this is what happens when they look around. So this is the search condition. They don't know that we will query their memory later on. Then we have a memory condition. So here you can see basically a laser pointer immediately showing you where the object is. And they just are told, in this particular scene, memorize this object in this location. Okay. And they get labels. They know exactly where the object is. We track their eye movements to account for gaze durations and so on. And then we have two ways of measuring recall. So no drawing this time. I think Dan was fed up with drawing. Or analyzing drawings of people. We had a memory test where we tested the identity memory, where we showed them objects and they were able to look at them and decide, is it an old, or it's basically an old new recognition task. But we also, and I think that's kind of nice when you do VR, had a location memory test. So here we gave them the scenes and the bunch of objects that we were interested in, and they had to position them in the locations that they were remembering. And so we get really detailed 3D coordinates of objects where they should have been and where they remembered them. And so here I'm showing you the accuracy data of the old new recognition task for the distractors. So of course we had objects in there that were never queried, and here we don't see any difference. But we see, again, for the targets in the search condition, or basically the critical objects in the memory condition, that we had a substantially higher accuracy for identities in the memory test in the search condition over the memory condition. And we see that memory superiority basically also for location memory. So basically when here you see the distance, so the smaller the distance, the better they remembered the location of those objects. And you can again see that the location memory was better in the search condition for targets than in the memory condition. So the search superiority that we had found previously in this older study is there for both object identity and location, also when you're moving around in 3D environments. Nobody's drilling. Somebody is maybe working on our lab spaces. Who knows? So to summarize part 3, intentionally memorizing object is less beneficial than incidentally echoing them during search. And this search superiority effect seems to be highly replicable and affects both memory and memory for object identity and object locations. Okay, I think now I have 5 minutes left, more or less, for the last part, which I think is also a fun direction of the lab, where we're basically wondering, how does this develop? Does this develop this kind of scene grammar that we're talking about? We're usually not born, and I see that with my kids too, and we don't know necessarily when we're little where things go. We learn that over time through exposure, through parents who yell at you and say, put that toothbrush back into the bathroom, right? So there's something that has to be developing over time. And so this is work that Sabine, one of my first PhD students in the lab, kicked off many years ago, and that Dilara, a current PhD student in the lab, is now continuing to do. I'm just showing you bits and pieces of this data. But I'm starting off with this video of a girl I actually have, I cannot show it to you right now, but I have a dollhouse here that has lots of objects in them. And the idea here was that we would ask our little participants, aged 2 to 4 years old back then, to equip the dollhouse according to their scene grammar. Of course, we didn't phrase it like that, but we asked them to put those items where they think they would be. And the idea of this whole study was we wanted to see if is there kind of an age of acquisition of either scene semantics or syntax? Are there maybe interactions with language abilities? And if so, I mean, that would be an amazing pre-verbal diagnostic tool for something like dyslexia, because oftentimes you can only diagnose this when kids start speaking, or even, only when they start getting into school. So that was the idea behind it. So in all of those studies, I'm just showing you now, of course, the visual cognition studies, but for each of the children, we had like long, boring language test batteries that we were running on them. In this particular case, now you can see this little girl. Where Sabine is basically saying, yeah, this, our stuffed animal doesn't remember where to put the things. You can see now this is a sink that she takes in exchange. She kind of realizes that this is a bathroom sink and this is a kitchen sink. We had always one particular object now we would call it anchor object or diagnostic object in each of those categories already. So they could kind of sense what room categories were there. This is the empty dollhouse where they were supposed to place those objects. And what is interesting, first of all, is that there are huge inter-individual differences in how children equip their dollhouses. You have child 1 and child 2 here. You cannot really see it in this overview, but when I zoom in, you can see it. Child 1 is very, what you would call orderly and scene grammar adapt, versus child 2 seems to have a different grammar going. In this case, I think the kid was basically saying all the big things go in this room, all the small things I put in something else. But there were huge differences. And of course, we accounted for the use of dollhouse or the existence of a dollhouse. Nowadays, it's not clear that people still have dollhouses at home. We all put this, accounted for that. What Dilara now did to kind of make it a little bit easier to analyze is she created 3D versions of the dollhouse and then scanned them, which made it easier to look at the object locations with a distance measure to determine their syntactic knowledge of whether they put it not only into the right scene category, but also within the scene category, how they placed objects in relation to each other. And this here I'm showing you some of the results of Sabine's work back then. You have the syntactic language scores on the x-axis. On the y-axis, you again have distance. So the smaller the distance, the closer they were to what we would call maybe grown-up scene grammar. And you can see that it's pretty much all over the place for 2 and 3 years old. But with starting as the age of 4, you can see some kind of relationship coming into play. So placing objects within a dollhouse, which we call syntax, seems to start correlating with syntactic language abilities starting around the age of 4 years in this particular case. Another measure that we used is here. This is a cucumber in a bedroom, so that was the semantic inconsistent object in comparison to, I think it was socks that we had there. And we had our children just kind of look through those images with other kind of cover-up task, again, looking for, I think, or interacting with one of the stuffed animals that we used in the lab. Sabine was really creative about this. And we tracked eye movements. And so we know, again, from previous work that for adults, you see longer dwell times on inconsistent objects. May they be semantically inconsistent or syntactically inconsistent compared to the consistent controls. This is basically what you see here on the right. In blue, you have semantic inconsistencies. In red, syntactic. In green is always the consistent control. And here you see in the adults, the gaze duration basically is strongly increased when there's a semantic or a syntactic inconsistency. But what was interesting for us, you can see on the x-axis also now the 2, 3, and 4-year-olds in comparison to the adults, is that over time, it's not really that people start looking, or children, as they develop, start looking longer at unexpected objects. To the contrary, what they do, they seem to be disengaging faster from predicted objects, right? So starting around, again, the age of 4, we don't see it as much in age 2 or 3. Less time is spent on consistent object. And this is how basically this kind of inconsistency effect, as we've seen it for decades in eye movements, I think can be explained when it comes to development as a faster disengagement of predicted objects in those scenes as we get older. So to summarize the last part, and then I'm done. We have seen grammar development as being characterized by faster disengagement of predicted information and processing elements in their context, may they be words and sentences, objects and scenes, tones as part of music, might involve similar cognitive routines. So to summarize all of those studies, scene grammar and aids search and boosts object perception in real-world scenes. We saw that anchors guide attention and also interactions in 3D environments. We also, I hope, you were able to see that search boosts memory for both object identity and location. This is also ongoing work that we're doing now with EEG. And language and perception might develop based on similar cognitive routines. Thank you very much for having me. I'm very honored to speak here, and I'm very happy for any kinds of questions that you might have. Thank you.
Wow, Melissa, thank you so much. This is such an exciting talk. I'd like to ask everybody to unmute yourself, and let's give Melissa a big thank you. It was really, really exciting. And you're okay with taking questions?
Yes, please, 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 please.
Okay, so of course, Jeremy. Okay,
yeah, he sits in the first row, even on Zoom, right? It's amazing.
Okay.
Sharon, you want to go first?
No, you go. I'll go after you.
So actually, this, I think, is a question that we worried about years ago together, and I'm wondering if you have new thoughts about it, which is that all of this scene grammar-y ability must have evolved, assuming that it evolved, long before we were living in indoor scenes, and long before we were putting objects in dollhouses and stuff like that. And it is, I mean, clearly there's a structure to the outside world, but the vast pile of this kind of work, yours, mine, and others, is done with indoor scenes.
Yeah.
And quite orderly scenes too. So what happens out in the...
That is a question that you should address to Ronja, he's starting her PhD in the lab, and she just sent me her PhD proposal because she's applying for the graduate school here in Munich. And one of the topics was like, how does this apply to outdoor scenes? And I mean, what I keep saying, because this question comes up often, right? And I think it's a very good question, that we haven't been able to answer it because 99% of our scenes are indoor scenes, and we only use outdoor scenes when we ask questions about scene categorization. I think if you would ask Daniel, right, who's an outdoorsy person in the Alps, and I think we've talked about this too, he probably reads the outside world and has a scene grammar of it that I don't have, and is able to probably find paths and mushrooms and other important things with a scene grammar that he can use based on, you know, the how green the sides of trees are, or where certain rocks change formations and stuff like that. So I think there is something to it. I think it's just, of course, in the situation where we are able to structure our own world as we're doing it in our own homes, and where we place objects to make brushing your teeth easier by placing, the toothbrush and the toothpaste near a sink. That, of course, is highly structured and probably a good start to study this. And I like the idea of Ronja also to kind of now go out there and maybe try to have a more systematic way of looking at something like scene grammar out there, because you're right. I mean, probably humans are not the only ones using some kind of grammar. Bees, I'm sure, have some kinds of grammar. So I think that would be interesting to look at. But I think it's just probably the ease of being able to study this is just, of course, that was the low-hanging fruit at the beginning.
Yeah, that's after all why we used to why all of the old visual search literature is random bits and pieces.
Sure.
Stuff on blank backgrounds, because we didn't have the ability to manipulate scenes.
Yeah, and we felt really adventurous going out into, like objects in scenes, and then now even going into 3D scenes, right? We might, create VR worlds where people are looking at forests and mountains, who knows?
So I see there are a lot of questions, but I said I'm going to go after, so I'm going to go quickly. Just a thought, and then so my thoughts are, I mean, in line with the idea. I mean, I think scene grammar is very much in line with statistical learning of visual information that we come across along our lifetime. And I think that, also the memory and the action that you show that is related to how, people can improve, and the fact that children learn it better because so I think they're utilizing the visual statistics of the information. They learn to use it, and it's kind of embedded in their knowledge. So I think you're probably likely to find similar things with the outside world. I mean, if you have a tree, on top of a roof, or, things like that. So it depends what maybe the anchors and stuff are going to be a bit different, but it sounds to me like it's all visual statistics. And that's, so I thought it's really nice. And I mean, I think it's very much in line with visual statistics.
I think that's also a good comment, because also, I mean, when I came to Frankfurt 10 years ago, the first people who approached me were architects and like landscapers, because they immediately thought, and we didn't even have the concept of anchors back then, but the way we talked about visual search was super intriguing to them, because of course landmarks kind of tie into this idea of anchors when you go more outdoorsy and you try not to maybe explain search but navigation, right? So I think there is something that could be interesting to kind of look at in between those literatures, because there's a huge navigation landmark literature out there that I have not covered yet that might tie nicely into, the idea of trying to explain search behavior maybe in real world environments. And then to your comment about statistical learning, I do agree that I think statistical learning is a huge part about it. But then again, I think the important thing about us humans learning this is, first of all, actions. So as I said, Lea in the lab is pushing the action front more. I think it's a very important part about how we perceive the world, how we understand it, how we, because we perform actions like brushing our teeth or cooking or baking, we sculpture our world, at least indoors, right? So it's not a passive kind of statistical learning as you know it more from the statistical learning literature, where it's like an encoding of things that are like basically being presented at you. And I guess there's something about feedback, right? So as I said, I mean, I don't know how many times I hear Daniel yelling through the house that everybody now come here and put your things in the right location. And no, this is not the right location. This does not go here, right? So I think there's also this component in here that is underexplored as well, which goes beyond, I think, statistical learning. And I think there is a lot of statistical learning in there. We will get quite far, but I think that we will see that it will only get so far. And I think the rest will have to be somehow explained by our human nature of exploration, interaction, education and culture, right? Yeah.
Yes, definitely. And also in individual professions and stuff like that, because, carpenter is not the same maybe as, other people. And
Exactly.
yeah, lovely. Okay, thank you very much. Are you up to more questions?
Oh yeah, absolutely,
yeah.
absolutely. Unless people keep drilling here and you still hear me, but I'm muting myself while they're drilling.
We don't hear the drilling, so that's good. So,
good.
Asaf, Ariel, do you want to unmute yourself?
Sure.
Mhm.
Hi. Thanks for a great talk. I'm just a little curious. Maybe I don't know, maybe more about like the philosophical foundations or
Mhm.
implications. So, maybe first one comment regarding is this more so scene perception can be viewed along multiple levels of explanation, from summary image statistics to action affordances. So I'm just wondering how what you term scene grammar is in fact more object in scene grammar. So it's more about object perception in context than it is about scene perception per se. And then just
Mhm.
as a broader point, um, again, it's a very useful analogy, as you've said,
Mhm.
but in terms of the kind of, notions of modularity of mind and things,
Mhm.
back in the 80s when we talked about modularity. So I'm just wondering, for instance, would you predict, to have an aphasic patient that would
Mhm.
perhaps have, problems in understanding objects in space?
Mhm.
So how far can you take this analogy?
Mhm.
That's my
Yeah,
second kind of
so I
question.
think two very good questions. So speaking to the last one, because I already forgot the first part, and will have to remind me. To the second part, I think that's an interesting question, and it's taking the analogy very far. I'm always kind of hesitant to kind of say this is so cross-modal and so amodal in the sense that one has to predict the other, and if you have language problems, it directly affects the way that you use your what we would call scene grammar. We see some indices of that, I think, with the language scores of children, where we also, of course, controlled for intelligence and other kind of variables. There seems to be something going on, and Dilara has been running studies with not aphasic patients, but with children with developmental language delay.
Mhm.
And here we also see some indices, but it's not a clear-cut thing. I would never, I think, be comfortable saying, yeah, this is so unified that the idea that I put out initially when I introduced this development of scene grammar part of having like a pre-diagnostic tool, I think is not straightforward. I would not, take eye movements on inconsistent objects that might not be as,
Right.
as strongly differing between consistent and inconsistent objects as saying
Yeah.
this kid will develop dyslexia or whatever. But I do think that the analogy is getting us some places, and I am not sure with aphasic patients. I could imagine that they might be having also built strategies that allow them to
Right.
function perfectly well in the visual world.
And regarding the question of objects, is this more of
Yeah,
a kind of framework for object and
yeah,
context perception,
yeah,
or more about
yeah.
scene, as
Thanks
you
for
said?
reminding
Yeah,
me of that
no problem.
part. So you're right that I mean this all came up based in my interest of searching for objects and scenes. So you're completely right that this is heavily drawing on all the great work that has been done on object perception, object search in naturalistic scenes. But in the lab, of course, we have people that I didn't show that today, where we have Sandro Wiesmann, for example, Verena Willenbockel in the lab, have done really cool work in the lab where they look at the influence of objects and summary statistics, for example, on the categorization of scenes as a self. But the scene grammar framework and something like the whole concept of anchors guiding your attention to certain local objects is heavily based on this kind of question of like, how do objects function, and what do we do with them and how do we perceive and interact with them in naturalistic scenes. So it is more heavily based on that object part than I would say this global perception of scenes, even though I think it goes hand in hand, right? I mean, when the model, also the dual pathway model is also, putting those two a little bit closer together and saying there's both going on and both seem to be very important and are probably interacting and influencing each other along the way heavily.
Great. Thank you so much.
Yeah, thank you for the great questions and for reminding me of the first.
Ethan, do you wanna? Yeah,
thank you. I'll just ask a very fast question. Thank you, Melissa. Just a question. Well, we know that how we are dependent on a feature extraction from every scene that we are seeing. And do you think that, for example, how grammar seeing could help us to extract features which are slightly deviated from their job? For example, when we go back to the toilet, if I change let's say, a roll toilet from a circle form, cylinder form to a cube form, it's quite not the thing. But do you think that still, because of the seeing grammar participant, would be more saying that, well, this is the thing, though the shape is a little different?
Yeah, that's a good question too. I mean, it goes into a little bit of the things that we've been talking about also, for your future pursuits in the lab. But I think the strength of scene grammar, or let's say just context of objects in their context, is that even if they're very blurry or they're occluded, and an example that I like to give is like recognizing the teddy bear underneath the blanket, right, in the bedroom, this hump in the bed, is something where context gives you strong predictions about what the object should be. So I think little deteriorations of features probably won't throw you off unless it really becomes so big that it might, just not be recognizable or something like that. But I think our ability to deal with occlusions or even feature changes and stuff like that and still recognize the object when it is still in the context is quite high. And I think if you would take the same object and change features and do kind of a change detection task or something like that and isolate that object and take it away from the context, you would probably be seeing those you would be much more sensitive to those. I think you can, get away with very blurry perception of this blob on top of the stove, whatever the visual features of this thing are, and still know that this is probably a pot or a pan, and you can exclude a bunch of objects that probably are not going to be resting there. Nurit, good to see you.
Hi there, good to see you too. And thank you for the beautiful talk. So I'll try to make it short because it's, I think I'm the last one probably. So I've been doing in the past some stuff with objects, with semantic and spatial associations, and I've been also trying to differentiate these two patterns of spatial versus semantic. But at some point, I think I reached a conclusion that many of my so-called spatial associations, which are a little similar to your grammatical ones, are in fact semantic and not pure spatial.
Yeah.
And it seems like in scenes, probably the main factors for like spatial location or spatial limitations, right, would be, first of all, gravity, right? You can't put something in the air or whatever. And size, right? You can't put something very large on something very small. But it seems to me that some of your associations may suffer from the same problem that I did in my own research, and I abandoned it for that reason.
No, you
like
shouldn't.
the toilet paper near the toilet or the toothbrush on the sink, right?
Yeah.
I mean, there's no limitation of putting the toothbrush on any other counter, right? But semantically, or maybe this goes back to Sharon's question, it just doesn't operate this way, right? Doesn't work this way in the world because statistically we're used to using the toothbrush near the sink, right?
Yeah.
Because of its function, etc., blah, blah, blah.
Yeah.
So how do you deal with this?
Yeah,
Sometimes
that's
the
good.
border is not clear between
Yeah,
what
I
is.
know. It's a very good. I love this question, and that is also something that when I talked to Ronja about her new PhD project, is also something that we might be looking at, and it's something that I've been thinking about differently now that we kind of came up with this kind of substructures in scenes. So before that, I had this kind of semantics, syntax. Semantics is inconsistent with the scene as a whole. Syntax is some kind of relation to objects. But I totally agree with you that when I started looking into this more and thinking about it more, is when I put like the toilet paper from the toilet phrase to the shower phrase, I would have called it a syntactic violation because it's still fine with the overall, scene. But now that we're kind of looking into, the hierarchy of this, and we can go down the hierarchy now and say, now we're in phrase land. Now on a phrasal level, this becomes a semantic inconsistency, right? If you have the phrase, the semantic phrase of showering, and you have a semantic phrase of like peeing, right? They go in the same overall scene, but they're very different, right? And they create huge inconsistencies, right? If you would also pee into your shower and stuff like that. But and there I think that also then became different, right? And I didn't think anymore of it. No, this is not a strict syntactic inconsistency anymore. It's actually now on the phrasal level, I would also say, it becomes semantic in a sense. So it is not as simple as I basically showed it to you initially here. It's like, this is semantics, this is syntax. I think it's really a measure of how you view on which level of the hierarchy you now look at relations of objects and what is the context, right? Is the context seen as a whole? Is the context the phrasal context? And maybe you can even go more fine-grained. You can even zoom out and say, I'm in an apartment, right?
Yeah.
And,
Exactly.
within there, it might be syntactically in a wrong location of this apartment, but it's actually a semantic inconsistency because it's,
Not any
measure of
location
perspective.
inconsistency is syntactic.
Yeah.
Just because it's location, right?
Yeah. Right. So I think I've walked this path, and I think it's an important path to walk, and I still have a few decades to work, and I think there's lots to do still to kind of see, how far analogies go, where they don't work, where you might want to drop that and look at this in a more continuous measure, like we did with anchor objects, right? Go away from this binary way and finding some kind of measure that gives you, something that tells you how, not having to call it semantic or syntactic anymore, but,
Yep.
Mhm.
Thank you.
No, thank you. Thank you all for your interest and for coming out and getting up early. Thanks, Jeremy, also.
Yeah, lovely.
And
This was really an exciting talk, Melissa. Thank you so much.
thank you.
It was really lovely having you. Yes, we can go again. And I want to say that next week we're going to have Morris Moskovich here doing memory. So I still don't know what the title of the talk is going to be, but I definitely hope it's going to be a good talk. I mean, I'm
Is
sure
it going to be at a semi-decent hour?
Yeah.
No.
The regular decent. I mean, for you, it's also still early, but I guess it's less early than 7.
Yeah.
Yeah. I mean, if for him, he also has to, so it's also
That's true. That's
yeah,
right. You got to get him.
not for us only.
No,
Yeah.
but I appreciate it. This way I can go back home
Yeah.
to
So I hope you have enough
But-
time to run for your
Good
training.
question.
Okay.
Should I
Thank you
email
so much.
Have
Yeah.
Thank you,
the link.
Melissa.
Okay.
Thank
So,
you.
Okay.
Ciao.
Okay.
Ciao.
okay. So bye.